Take a look at this one. Just a log squared and absolutely nothing else. No product to split, no inner function with its derivative waiting next door. Every tool you'd normally reach for has nothing to grab. But that lonely log is hiding a door, and one substitution swings it wide open. So here's the move. If the log is the problem, make the log the new variable. Let u equal the natural log of x. Flip that around. E to the u is x. Now differentiate. Du by dx is 1 over x. Rearrange. X du equals dx. That little box line is the bridge. It carries the whole integral across into u. Now swap everything in. The log squared becomes u squared, and dx, remember the bridge, becomes x du. So the integral now reads u squared times x du. Which looks tidy, but look closer. Something from the old world is still in the room. There's still an x in here, and the u integral can't keep it. Every last piece of x has to go. But we already paid the toll, back on the very first line of the setup. E to the u is x. So that straggler becomes e to the u as well. And now, at last, the whole integral speaks u. Now look at the shape we've landed on. A polynomial times an exponential. And that's the friendliest pairing in calculus, because u squared can't survive being differentiated. Step down again, and it's just a number. One more, and it's gone. The exponential? Unbothered. It soaks up every integration. So we hit it with integration by parts, twice. And there's a table that does all the bookkeeping for us. Here's the table. Down the left-hand side, we differentiate over and over. U squared, 2u, 2, 0. The polynomial dies right on schedule. Down the right, we integrate, and e to the u just keeps coming back every single time. Then the signs, plus, minus, plus, alternating all the way down. That's the entire machine on one little grid. To read off the answer, you multiply along the diagonals. Plus u squared, e to the u, minus 2u, e to the u, plus 2, e to the u. And the 0 row wipes out everything past it. That's the signal to stop. Stick the constant on the end, and the u world is finished. 2 rounds of parts in one clean sweep. One last move. U was never the real variable. It was a disguise. So unmask it. Every e to the u is just x, and every u is the log we started with. Swap them back, tidy it up, and there it is. From a log we couldn't even touch to 3 terms any student can differentiate. Box it. Done. Want proof it's right? Differentiate the answer. The product rule fires, the middle terms eat each other, and you land exactly where we started. So, the takeaways. When a log blocks the road, make the log your variable. When you swap, swap dx too, and any leftover x becomes e to the u. And when a polynomial meets an exponential, parts until the polynomial dies. That's the whole game.